Next up, for example 6, integrate. We have the antiderivative of x cubed plus x over x minus 1 with respect to x. Okay, notice if you will. This one is violating the principles that we've established so far, where the numerator's degree is bigger than the denominator's degree. So this one is not going to be of the form du over u kind of business, right? Okay, so let me scroll back to and take a look at the steps. The very first step that we want to do that we have not had an opportunity to see is, if your fraction's improper, the very first thing that you need to do is divide, and the only thing you do partial fraction decomposition on is the remainder, stuff that's left over. So take a look at the rational function here. That line means divide anyway, right? Okay, so I can do long division on this, but it's really convenient that this is just x minus 1 in the denominator. We can do this one by synthetic division. We have the number 1 on the outside. Inside the box, 1x cubed, there's no x squareds, 1x, and then there's no constants. Got to fill in your little zeros, or you're going to get the wrong answer. So again, it's probably been a minute since you've done some synthetic division. The first thing is you bring down the 1, and you multiply. 1 times 1 is 1. Now you add. 0 plus 1 is 1. Multiply it times the 1 on the outside, 1. Add 2. 2 times 1 is 2, and add, we get 2. This 2 out here is the remainder. So we want to rewrite our problem thusly. So this is equal to the indefinite integral of, now think about this for a second, what should the power on this first one be? We took x cubed and divided it by x, so we subtract the exponents, it should be x squared plus x plus 2. And notice that if this is all we had, there's no need for partial fraction decomposition on this one because it's just a quadratic. We can very easily find the antiderivative. And then finally, plus 2 over whatever it was that we divided by, which is x minus 1 dx. Okay, so if I were going to do partial fraction decomposition, it would only be done on this last term here. Except I don't have to do it because really it turns out to look like one of these things that we already had. It's already in the form of the antiderivative being the natural log. So it's good to go. We're just going to take the antiderivative of this term by term, and in order for me to make room, let me move this guy over here. Okay. And then term by term, antiderivative x squared is x cubed over 3 plus an x squared over 2 plus a 2x, so there is the quadratic part. And then the antiderivative of this, as we've seen, if you wanted to, you can do a u substitution. It's not going to do much to it because du is equal to just dx, and there's nothing to fix. And it does take on the form of a du over u, which is the natural log. Bring down the 2. Switch back to your blue crayon. 2 natural log absolute value of x minus 1, and then plus c. And then I don't know, it's entirely possible that they rewrite this in some kind of way. Like, for example, this 2 can come on the inside instead of it being the coefficient. Make this squared. And then not only that, since it is squared, which turns out to be a positive number, we can actually get rid of the absolute value bracket. So it's entirely possible that your final answer looks like that as well. All right, that's done.